Welcome to the first lesson of week 3. In this lesson you'll learn more about 2's complement numbers and how to use them to carry out binary subtraction. In this lesson we'll recap what we've learned already about 2's complement minus numbers, and we'll learn an easy way of converting any binary number into its negative equivalent. And then we'll use this technique to carry out binary subtraction sums. So first let's recap what we learned last lesson about 2's complement numbers. In a 2's complement number, the most significant bit, that's the bit with the largest value, has a negative value. All numbers are composed, therefore, of a mix of positive and negative values. To convert a 2's complement number to decimal, put the bits of the number into the position grid and then add every position value where you see a 1. So in this example, minus 128 plus 16 plus 8 is minus 104. Work that out for yourself if you like. There's an easy way to convert ordinary positive binary numbers to negative numbers. So if you have to make a negative number in binary, the easiest way is to make the positive number using the method you already know, and then use this shortcut. And the shortcut is as simple as this. Create the positive number, flip all the 1's into noughts and noughts into 1's, and then add 1. So let's look at a worked example. Supposing we had to create the number minus 99 using 2's complement. The easiest way to do it is to make 99, 64 plus 32 plus 2 plus 1 adds up to 99. Now let's turn that into minus 99. Flip all the bits so that 0 becomes 1 and 1 becomes 0. And then simply add 1. And that's minus 99. Here's another example, minus 20. Make 20. 16 plus 4 is 20. Flip all the bits and add 1. It's a slightly longer process because there's a couple of carry bits, but that is minus 20 in 2's complement. You're allowed to use this method in the exam, and it's a very quick way of making negative numbers. So here is a short test, 6 examples of negative numbers, minus numbers. Show all of those numbers using 2's complement. So if you're doing this in class, we'll write it on paper and mark each other's work. But if you're doing it on your own, watching this video, stop the video now and write those answers out so that you can test your own ability. The right answers are on the next slide, so stop the video before you go on to the next slide. And here are the answers. Check your work. If you got it right, well done, you understand the principles. If not, go back and review the previous slides to see if you can see where you went wrong. So to recap what we've learned so far in this lesson, 2's complement is a way of expressing binary numbers, and they range from minus 128 to plus 127. The most significant bit of a 2's complement number stores a negative value. And there's an easy way to make minus numbers. Create an ordinary number and then flip all the bits and add 1 to convert it into a minus number. Now that we know how to create minus numbers, we can use them to do binary subtraction. And this uses an obvious principle in maths that subtracting a number is the same as adding a negative number. So when we do a binary subtraction, let's call the two numbers x and y. To calculate x minus y, we convert y to minus y, and then we add the two numbers together. So let's look at a worked example. Imagine we had to carry out this binary subtraction. We begin by looking at the second number. Let's write it out. And now we're going to turn that into a minus number, into a negative value. We flip all the bits and we add 1. We've now got a minus number. Here's that minus number. And now we're going to add the first number to it. So here are the two numbers. The second number is now a minus number. So if we add them together, that's the same as doing a subtraction. And the addition sum is quite straightforward using the rules of binary addition, which we've already learned. So remember, make the second number negative, add it to the first number, and remember when you're doing this in the exam, show you're working. So now you can try it for yourself. Here's a binary subtraction sum. I'll give you the answer in class. And there are more examples of binary subtraction in the next lesson.